Assalamualaikum warahmatullahi. Okay, welcome to EMJ 32204 Electrical Machines Laboratory Module number 2, Characteristic of DC Generator. Okay, within this lab module, we shall have 70 marks total. We will perform in group to characterize the DC generator. We have done the DC motor previously, so now we are focusing on the DC generator. So we shall have a objective of listed here. You are able to compose, simulate, and characterize a separately excited DC generator using SPICIM. So we have this generator on separately excited on DC shunt, but for this module we focus on the separately excited. Means that we have a field circuit with its own voltage source. Meanwhile, our armature circuit or the terminal circuit which produce the voltage into the load is from another source. Okay, actually there is no real difference between DC generator and motor except the direction of power flow. So we have seen before our power flow of motor, which is the power delivered from the source into the motor. So the motor connected to the shaft, it produces mechanical rotation. Meanwhile here, the shaft itself is being provided with external generation force. We will turn the shaft and turn the motor, the rotor, and it will generate current delivered to the terminal. So, but in terms of field, we shall have a separate source from this terminal voltage, such that this field providing a terminal voltage and the current still flow into the RF and LF. So the product of our generator should be in terms of their terminal voltage. That's why we measure or we perform the performance, or we measure the performance of our generator in terms of their voltage regulation. When we tap the terminal output into load, it produces electrical output. When the load is low, so how much the measured terminal voltage, and when we put the highest current, the rated current load, which draw the current at the rated current, so how much the voltage being dropped to. So we measure, compare these two kind of voltage difference. So that is our voltage regulation of our generator. So in terms of the how we want to control in terms of their produce or their voltage output is by prime mover rotation speed adjustment. So the speed of the shaft we adjust accordingly. The higher the speed, so the higher the voltage produced. The lower the speed, the lower the voltage produced. Just same like our dynamo which attached to the wheel of our bicycle. All bicycle use dynamo. So the higher you turn your bicycle wheel, so the higher, the brighter the light produced at your bicycle. So it follows the same concept. And another kind of control is by field control adjustment. Means that we control the voltage here. The higher the voltage we put in to the RF circuit, to the field circuit, so the higher the IF will go into the will pump into the circuit. The lower the voltage, the lower the current. So that's the two kind of adjustment or control for this separately excited DC generator. Meanwhile, the characterization of the performance of the generator itself, this is how we control. And how we want to measure the performance is by terminal voltage of the versus the load current. Okay, terminal voltage. So you shall plot the end product of your experiment using this kind of graph. So we are probing the terminal voltage load current characteristic. So the terminal voltage is your VT here, versus your load current, which is IA here. So we shall plot in terms of the response. When you increase your IA, so how much your VT? Means that at IA or certain value, you will get your VT at this point. And so you plot, this is the point. Then you increase your IA, and increase your IA. Then you plot another point of VT. Let's see, it was here. Then another point. Then you plot the response or graph response of IA according to VT according to your IA. And it was a expectation from our theory that once we increase load, which is this IA, for at the same time our voltage terminal will drop. So this is the voltage regulation of our generator. And the higher the IA, the lower it becomes and it will drop. So IA versus the voltage, terminal voltage versus IA. So that's the first graph you need to produce. Then the terminal voltage versus field current characteristic. So your field current here, when we adjust the field current, means that when we adjust in terms of your voltage up or down, so for sure the field current will rise or will drop. So the terminal voltage versus field current, and your VT versus IF. So how is going to be? Is it going to be increased? And when you plot with the several points, at least 5 or 6 points, or is it going to be decreased? And the terminal voltage versus IF. So you shall produce this kind of graph to see the response. So per graph, you just comment what is the response here. Per graph, you just comment what is the observed trend and point. Minimum, maximum, the trend is growing up or going down. So is your comment. Then your voltage regulation of your system. So means that your VR. So VR means your terminal voltage versus what? It should be versus load, and voltage versus load. So you can calculate, but actually we can calculate up front what is the theoretical graph it should be. Then when we plot, we shall compare between the experiment and our theory. Okay, in terms of procedure, you shall use the same circuit of the DC machine, but the connection will be in terms of shunt, in terms of separately excited, but for the prime mover circuit, we connect in the shunt. So the prime mover will be your motor. So the motor, we have a shaft, and this shaft will be connected into your generator. So the prime mover, you can follow the circuit with the default parameters of the DC machine. It will turn in 1200 RPM. All the data or the parameter you can follow the default, or you can retype according to this scheme. And use another, after the shaft should be connected into mechanical coupling block. So this mechanical coupling block will connect into your DC generator. And so this DC generator will be connected in separately excited. So this RF here have their own voltage terminal. Your output terminal here will be connected to your load. So the load just use the same concept of our previous lab, which is connected into your resistance, simple resistance. So you will control the current by using Ohm's law, which define what kind of voltage, what kind of current you want to set. So what kind of resistance you have to put in to the circuit. Means that you can use open circuit to measure the open circuit voltage. Then you put in the resistance. Resistance to represent, based on your calculation, how much you want to absorb from the motor. So that's the resistance you will have to put at the circuit. So complete the end circuit of your separate DC generator system. Place necessary measurement of voltage and current to acquire data of your experiment. So present the schematic, the system schematic diagram using initial voltage, field voltage of 120 volt. So the field connected with to the 120 volt of voltage value. So 4 marks for that, for your circuit. Then within the simulation, vary the output armature current to observe the response. So how you want to vary the output current is by varying the resistance, as what I told you just now. Okay, and so you measure and observe all the responses, including voltage terminal output, also the input and the output power. How much you want to see, how much the efficiency or the P in and P out of our system. So you need to adjust the load resistor. So you can use the value of 100 kilo ohm down to 5 ohm. So you should separate accordingly, not in range but maybe in deca range. And so you can use that one. You can see, you can try and see, and you can repeat again. Set at least 6 data points throughout your experiment, 6 data points to produce a reliable graph. Then simulate in 5 seconds. Previously we have 10 seconds of simulation, so you can use 5 seconds instead to speed up your simulation, and present your result in proper table, like I told you before. Per table and per graph, you put a comment. So present the related scene view, screenshot, same per lab 1. And use Excel plot, discuss the trend of terminal voltage versus load current, and like I told you before. So you produce a graph and you comment below your graph. That's for your response compared to the variation of your load current. Then the speed control. Second is your speed control. So now you use voltage regulation or voltage variation on the field terminal. Then you see what is the response of your system. So using Excel plot, also plot the VR of your system. So discuss why we use this 10 kilo ohm down to 5 ohm in this experiment. So once you generate the graph, you can see the justification of this value. Okay. Then suggest another field control. Other than that, two kind of control. How we want to control the output voltage of the DC generator. Then conclude. Means that you suggest and discuss. Then conclude your overall discussion of this experiment. And that's for your lab report. Then this part is regarding your lab demo. So for this lab demo, produce a maximum of 5 minutes demo to show overall of your lab per this rubric in terms of your organization, your procedure, your result, and your discussion, analysis. So you conclude in presentation of recorded. You can use any kind of recording device or material or procedure. So you produce in 5 minutes video, upload to YouTube or whatsoever media, and share the link to the Google Classroom later. Okay, that's all for briefing of this lab 2. So if you have any question, you may ask. Thank you very much.